everyone. Thank you for joining me. I'm so glad you made that extra effort to ensure that you do well on the test. I suggest that you pause the video and work the problems out before you reveal the answer. I am confident by watching this video and practicing along with it that you're going to definitely increase your chances of getting a high score on the test. Now, one thing I want to make a note of, this video was made with both new and old voiceovers, so the numbering of the problems may not coincide with what you see on the screen in terms of order of 1, 2, 3, and 4. So just disregard that. Other than that, good luck and do your best. In this example, we're going to locate points on the rectangular coordinate system. Now recall from the lecture in class that we indicated our first value of an ordered pair is your x-coordinate, and it tells you where you're going to move along the x-axis. If it's a negative, you move to the left. If it's a positive, you move to the right. If it's 0, you will not move at all along the x-axis. The second value indicates your y-coordinate. If it's a negative, you will move down. If it's a positive, you're going to move up. And if it's 0, you will not move up or down along the y-axis. So since we're given the value -5, -4, that means on the x-axis from the point of origin, we're going to move -5, which means we're going to move 5 to the left. Our second value is a -4. That tells us our y-axis or y-coordinate. Because it's negative, we're going to move down from that point, which takes us to letter I, which is choice B. In this next example, we're given the ordered pair 0, 2. So on the x-axis, because there's a 0 in x's place, that means we will not move at all on the x-axis. So from the point of origin, we're just going to remain right there at that point of origin, which is 0. Now our y value is 2. So remember, y value, your y-coordinate tells you you're going to move either up if it's positive, down if it's negative, and if it's 0, you won't move at all. And since it's 2, a positive, that means that we're going to move 2 up from the point of origin. That takes us to letter C, which is choice C. In this example, we're going to determine which quadrant a point is located. So recall in the class lectures, I've mentioned to you several times that you should know where a point is located based on their signs, not based on the number. Because if you look at this, it may look intimidating because you see this fraction. But we don't care that it's a fraction. The fact is, the first value is a positive. The second value is a negative. And if you look at the rectangular coordinate system, for a positive, you would go to the right, and for a negative, you would go down. So any coordinate or ordered pair that has a positive and a negative is automatically going to be in quadrant number 4. So know your quadrants based on the signs, not based on the numbers, and that way you don't have to stress if you're given, let's say, a fraction or a decimal or a large number. Just pay attention to your signs and you'll always know where the point is located. In this example, we're going to interpret a line graph. Now, I just want to make a note on the test itself. The only way I can prepare you for interpreting a line graph is to just give you some tips on making sure that you pay attention to your titles. So you pay attention to the x-axis. What it means here on the x-axis is referring to the monthly average. And then on the y-axis here, it refers to the number of rig drillings. So pay attention to that, and then look at your points, read the question, and then just answer it based on that. But just because you see this particular example doesn't mean you're going to have this same type of example. It could be any type of question related to that line graph, but just make sure you read all your labels, and that will help you to be able to interpret the data. So let's begin. The question says here that the number of rig drillings decreased by how much from 1982 to 1986. So let's take a look at 1982, the first year we were given. If we follow where the point is located at that year, so it is at 4,000. And at 1986, it is approximately, okay, it's a little bit more than 2,000. So if you have 2,000, then we have 3,000. So what would be in between that mark? Yes, it would be 2,500. So 2,000, then 2,500, then 3,000. So that mark then of 1986 is located at 2,500 because it's the middle point between the 2 points. So then if you want to know how much it decreased by, because we can clearly see that from 1982 to 1986 that there was a decrease. So to see how much it decreased by, all you need to do is subtract the two numbers. So let's go ahead and subtract that 4,000 minus 2,500, and what we're left with there is 1,500, and that is the amount that it decreased by. In this example, we're given a scatter diagram representing the relationship between the amount of time spent practicing, minutes per day, to the number of free throws made. And notice if you look at the scatter diagram, your dots, which is your data, is moving from left to right in an upward motion, which indicates that that is a positive correlation. So we can already eliminate choice A and E, because we see there's a positive relationships. In terms of describing that relationship, well, recall we can start with our x-axis here and notice that along the x-axis that it is, as you go along, it's increasing. So for example, if we move to 10, we see that our data is at a point, let's say 32 or so. Moved up more, increasing to 20 on your x-axis. Notice we're increasing, and so is your y value is also increasing. Move up again on the x-axis, same thing, y is also moving up and increasing. So between these two relationships, what you see here is an increase, which means that as the amount of time spent practicing per day increases, so does the number of free throws. They increase as well, which is choice C. So positive correlation to describe that relationship. As the amount of time spent practicing per day increases, the number of free throws made increases. And there you have it. In this example, we're going to determine ordered pair solutions. Determine whether the given ordered pair is a solution for the given equation. So we're given the equation 4x minus 5y equals 8. And we're given the first order pair of 2, 0. So we're going to plug in a 2 for x and a 0 for y. We want to plug it in and see if we're left with a true statement. So on the left side, we're going to go ahead and calculate it. 4 times 2 is 8. And any number multiplied with 0 is going to be 0. So what that leaves you with is 8 on both sides. And that is a true statement that 8 is the same as 8. 8 is equal to 8. So therefore, that's your proof that yes, the ordered pair of 2, 0 is a solution to the given equation. Now let's use that same equation but plug in a different point. We want to see if 3, 1 is a solution. So we're going to plug in a 3 for x and a 1 for y. When we do so, it's going to look like so. Let's go ahead and do the math. On the left side, we have 4 times 3, which is 12, and 5 times 1, which is 5. So that's going to be 12 take away 5. 12 take away 5 is 7, and 7 is not the same as 8 on the other side. That is a false statement. When it leaves you with a false statement, that is your proof that no, that ordered pair is not a solution to the given equation. A section of a roller coaster track has the dimensions shown in the diagram below. Find the grade of the track. Now recall, to find the grade is nothing more than simply finding the slope, except with grade we write or represent our answer as a percent. So let's first find the slope. Recall, the slope is your rise over your run. And so our rise of the track is nothing more than its height, and at this point it's 8.8 meters. And then we have our run. So on the bottom of our fraction, our run here has a run of 20 meters. So let's go ahead and write that as a fraction. We have 8.8 over 20. Go ahead and get your calculators out and calculate 8.8 divided by 20, because it's always top divided by the bottom if you want to turn it into a decimal. And so what the calculator is going to give you is the decimal form, which is 0.44. Now again, recall that grade, we need to represent our answer as a percent. And how do you turn a decimal into a percent? If you said move 2 places to the right, then you are correct. Let's go ahead and move that decimal place 2 places to the right and insert a percent symbol. And what that gives us is 44%, which is choice D. In this example, we're asked to determine the slope and y-intercept of the equation 2x plus 5y equals 10. Now, the first step to finding the slope and the y-intercept is to rewrite the equation in slope-intercept form, meaning solve for y. So the first step towards solving for y, we're going to go ahead and subtract 2x from each side. What's our next step to solving for y? If you said divide by 5, that is correct. So remember, what you do to 1, you must do to both sides there of the equation. So let's go ahead and divide by 5. Once we simplify that equation, we are left with a line of y equals negative 2/5 x plus 2. How did we get that? Recall, with a fraction, anytime you have the top or the bottom of a fraction is negative, it makes the whole fraction a negative, so that's negative 2/5. 10 divided by 5 equals 2. And now that we have our line in slope-intercept form, recall, whatever is in front of x is your slope. And whatever is in the back is your y-intercept. If you want to write it as an ordered pair in terms of its location, it would be located at 0, 2. So that leaves us with which choice is the correct answer? You got it, choice A, and there you have it.
In problem number 1, we are asked to use the graph below to find the slope of the line passing through points A and B. The correct answer is C. One method we can use to solve this problem is the slope formula. Recall that if you know any 2 points on a line, you can plug the points into the slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So step 1 is let's identify the 2 points on the line. So where's point A? If you said -2, 3, that is correct. And where's B? That is correct. 1, -4. So now we can go ahead and plug these 2 points into the slope formula. So again, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Notice I colored them, the various colors, so that you are able to see how they are plugged into the formula. So once we plug them in, it looks like this. On the top, we have the signs are the same. Keep the sign. We want to add the numbers. That's going to give us -7. On the bottom, we have a double negatives, -2, but with a negative in front of it, it becomes +2. So that's going to give us 1 plus 2, which will give us 3. So our slope then is -7 over 3, which is the same as -7/3 as our slope. Another method to solve this problem is to use the rise over the run. Now recall the slope of the line is the ratio of the vertical change, represented by the rise between the 2 points, and the horizontal change, represented by the run. Now, when you see rise, that means that's a vertical move. To rise is to go up, and to fall is to go down. A run represents a horizontal move. If you run to the positive direction, that produces a positive number. And if you run in the negative direction, that produces a negative number. So it really doesn't matter which point you move from A to B or from B to A. On this particular slide, we're going to move from point B to A. So to move from point B to A, we're going to rise up 7 and run 3 to the left side. So that's going to produce a negative number. So our slope then is 7 over -3, which is the same thing as -7/3.
In this example, we're asked to find the average rate of change. Now recall, average rate of change is nothing more than simply finding the slope of a line. So let's go ahead and begin the process. So to find the average rate of change, or to find the slope, all we need to do is to pick any 2 points on the line. Now, since we have a line segment here, we can just take the 2 endpoints there and plug those 2 endpoints into the slope formula. So the first point would be 0 and up 25, so 0, 25. Your next point is located, let's see, over 5 and then up 15, so that would be 5, 15. So taking those 2 points and plugging them into the slope formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1, meaning subtract your y's, make sure they're up top, subtract your x's, make sure they're down below. So when we plug those into the slope formula, it's going to look like so. Subtracting the top is going to give us a negative 10, and the bottom is going to give us a 5. Negative 10 divided by positive 5 is going to give us negative 2. So we have a slope of negative 2. We have a negative slope. And that's right in line with what our line looks like. Notice our line is moving from left to right in a downward motion, which indicates that that is a negative slope. Now here we're talking about the value of a car in thousands of dollars. So this negative 2 here is going to represent negative 2. So the average rate of change was negative 2,000, which is choice A. In this example, we're asked to write an equation of line passing through the point negative 3, negative 2 with a slope of 3/4. We're also asked to write our answer in standard form. Recall standard form is where x is first, then y, and then the constant number is by itself on the right side. Notice all of our answer choices are in standard form, so when we finish writing our line, we need to make sure that it is in that form. Let's go ahead and proceed with solving this. Recall that to write an equation of line, that you need 2 bits of information. You need to know the slope, and you need to know a point. We have both of those, so all we need to do now is to plug it into a formula. Recall, it's one or the other. You can use the slope-intercept formula, which is y equals mx plus b, or you can use the point slope formula, which is y minus y sub 1 equals m times quantity squared x minus x sub 1. Whichever one you choose is fine. Just recall that our given value, we were given an ordered pair of negative 3, negative 2. In x's place, we have a negative 3, so everywhere you see an x, you're going to replace it with a negative 3. In y's place, we were given a negative 2, so everywhere you see a y, you're going to replace it with a negative 2. Now, if you're using the point slope formula, remember, you're going to plug in the sub 1 points. So in y sub 1 is where you would place the negative 2 if you're using the point slope formula. Let's go ahead and proceed first with solving it using the slope-intercept form. So remove y and replace it with negative 2. Remove m and replace with the given slope of 3/4. Remove x and replace with the given x value of negative 3. When we do so, it's going to look like so. So on the right side, we're going to multiply the fraction and the whole number. Remember, whole numbers, if you like, you can write them as over 1 if you want to write it as a fraction. And what we would be multiplying for the numerator then would be positive 3 times negative 3, which is negative 9. And on the bottom, we would have a denominator of 4. Now, when you're using the slope-intercept formula, you're always going to be solving for b because it's the only value you weren't given. So to get b by itself, we're going to have to add 9/4 to each side. And so what you have on the left side is a whole number of negative 2 and a fraction of 9/4. Now, I'm not going to cover that in this video, but you should know how to add, unlike fractions. So again, if you have a whole number, you can write it as over 1. Once you do that, in order to combine those fractions, you have to make sure they have the same denominator. So find the LCD. So in this case, it would be 4. So I have to multiply both the top and the bottom of that negative 2 over 1 fraction so that they will have the same denominator of 4. Once they have the same denominator of 4, all you have to do then is just simply combine the top. So with the second fraction that we converted, negative 2 times positive 4 is negative 8. So what we have is 9 minus 8 as our numerator with our common denominator of 4. So that's going to leave us, when we combine those two fractions, is 1/4. So putting our line together, then our line would be y equals, we were already given a slope of 3/4. So y equals 3/4 x, and we just found out that b is 1/4. So when we put it in the back, our line is y equals 3/4 x plus 1/4. For those of you who prefer the point slope formula, you're going to go ahead and plug in your values. So recall, for the x and y, you will plug them into the sub 1 points. For m, you're going to plug in 3/4. So when we do so, it's going to look like so. Remember, double negatives become positive, -2, but with a negative in front of it becomes +2, -3, but with a negative in front of it becomes +3. On the right side, let's go ahead and use the distributive property. 3/4 times x is 3/4 x. 3/4 times 3 is 9/4. Last step to solving this, we want to solve for y. Subtract 2 from each side, and y equals 3/4 x plus 1/4, the same answer we got using the slope-intercept formula. Now recall here, our answer choices are in standard form, so we need to rewrite this equation in standard form. So to do that, we need to get x on the left side. So let's go ahead and subtract -3/4 x from each side. Now, this is not the correct form for standard form, because the coefficient of x cannot be a negative or a fraction. It's both in this case. It's a negative and it's a fraction. And whenever it's both, you have to multiply by a negative. So take the denominator, in this case the denominator is 4, and we're going to multiply by -4. And recall, with equations, whatever you do to one, you must do to all. So once we multiply all three parts of the equation by -4, we're going to do our cancellations. Recall, with our signs, for the first term, a negative times a negative is a positive. So that's going to leave me with a positive 3x for my first term. Second term, we have a -4 multiplied with a positive y. That's going to give me -4y. A negative and a positive multiplied together will always give you a negative. Same thing for the last term. You have a positive fraction multiplied with a negative whole number, a positive and a negative. It's going to equal a negative. So what we have left there is -1. So standard form of that equation would be 3x minus 4y equals -1, which is choice A. In this example, we're asked to find the slope-intercept form of the equation of the line through the point -1, 5 and parallel to the line 4x plus 2y equals 8. So we're asked to write our answer in slope-intercept form, meaning solve for y. Notice all of the answer choices are solved for y, so we need to make sure when we're done our equation is in that form. Now we're asked to write a line that's parallel to the line that we're given. What do we know about parallel lines? Well, parallel lines, recall, have the same slope. So whatever the slope is of this line that we were given, our slope of our line that we're going to create is going to be the very same slope. Now right now we don't know what the slope is of our given line because we have it in standard form. So our first step is to rewrite that in slope-intercept form so that we can find out what our slope is. So to do that, we need to solve for y. First step to solving for y in this given equation is to do what? If you said subtract 4x from each side, that is correct. Last step to solving for y is to do what? Yes, divide by 2. So once we divide by 2 and we simplify our line here, our equation, what we are left with is y equals, and here we have negative 4 divided by positive 2. That's going to give us a slope of negative 2. So negative 2x. And then 8 divided by 2 equals 4. So our line is y equals negative 2x plus 4. Now the only reason that we rewrote that in slope-intercept form was we wanted to know what the slope of this line that we were given. So the slope of our given line is negative 2, which means the line that we're going to create, it must also have a slope of negative 2. So if I was taking a test and I'm looking at my answer choices, I would need to make sure that whichever one I chose, it had a slope of negative 2 because they asked us to find an equation of line that was parallel to the one that we were given. And the one that we're given here has a slope of negative 2. Parallel to that would also have a slope of negative 2. Now we have not created our new line. So if you chose negative 2x plus 4 as your answer to this problem, that would be wrong. That's our given line. We have not yet created our new line. Let's go ahead and do so. Remember I said the two things you need to write a line. You need to know the slope and you need a point. Well, we just found out our slope is going to be negative 2. Our given point we were given was negative 1, 5. So whether you use the slope-intercept formula or the point-slope formula, whichever one that works best for you, in m's place, you're going to plug in a negative 2. In x's place, you're going to plug in a negative 1. In y's place, you're going to plug in a 5. So let's go ahead and plug it into one of those formulas so that we can identify what our new line is. So I'm going to go ahead, for the purpose of this slide, use the slope-intercept formula. So I'm going to remove y and replace it with our given value of y, which is 5. Remove m and replace it with our slope of negative 2. Remove x and replace it with our given value of negative 1. When we do so, it's going to look like so. On the right side, we're going to multiply negative 2 times negative 1, which is positive 2. Our last step to solving for b is to subtract 2 from each side, and b then will equal 3. When we put our line together, our slope, remember, is negative 2. So y equals negative 2x plus 3, which is choice D. And there you have it. We have created a line that is parallel to the line that we were given. In this example, we're asked to find the slope-intercept form of the equation of the line through the point negative 3, 8 and perpendicular to the given line 3x minus 4y equals 23. So recall, to write an equation of the line, I told you that you needed to know two pieces of information. You need to know the slope and you need to know a point. Now we were not given the slope, but we were given a point. So what we need to do is find the slope. How can we find the slope? Well, to find the slope of our given line, all we have to do, recall, is to simply rewrite this equation in slope-intercept form. Right now it's in standard form, so you really can't tell what the slope is until you rewrite it. And then once you rewrite it, whatever is in front of x will be your slope once it's in slope-intercept form. So let's start by solving for y, because that's what slope-intercept form is going to be. So to solve for y, we're going to have to subtract 3x from each side. That would be step 1. What's our next step to solving for y? That's correct. If you said -4, let's go ahead and divide both sides of the equation by -4. Once we simplify that and clean our equation up, and be mindful of the signs. So on the right side, a negative divided by a negative, that's going to give us a positive slope, so positive 3/4, and it's going to give us a negative y-intercept. But we're not interested in the y-intercept. All we needed to know was what our slope is. And what is your slope? Yes, it's 3/4. That's all we needed from that given equation, because we're asked to now to create a new line that's perpendicular to that given line. And remember, with perpendicular slopes, they are reciprocal of each other. They are opposite reciprocals. In other words, the slope of this given line is 3/4. So a slope perpendicular to 3/4 would be opposite sign, which is a negative, and I'm going to flip the fraction. So it would have a slope of -4/3. Okay, and that was all we needed from that given line, was just to identify what the slope is. Once we know the slope, you make sure you rewrite the new line with a slope that is perpendicular to the one that is given. So perpendicular would be -4/3. And now we're going to go ahead and use that point we were given, which is -3/8. So I'm going to go ahead, for the sake of time, I'm going to use the slope-intercept formula of y equals mx plus b. And so what that means is we're going to remove y and replace it with our given value of y, which is 8. Remove m and replace it with the perpendicular slope, which is -4/3. Remove x and replace it with the given value of -3. When we do so, it's going to look like so. We can go ahead and cancel those 3's. Now we're not canceling the signs there. We're just canceling those 3's. Remember, a negative multiplied with a negative is going to give me a positive. So that leaves me with just a +4 plus b on the right side. Last step to getting b all by itself is to, you got it, subtract 4 from each side, and b equals 4. So putting your line all together, your line is y equals -4/3 x plus b is on the back, which is 4. And that leaves us with answer choice C. So what we did here was we were given a line, and then we were asked to create a line that was perpendicular to that line. And so that is the reason into our new line we plugged in a perpendicular slope of -4/3. And there you have it, writing equations of lines perpendicular to a given line. In this example, we are given a function f of x equals -3x² plus 2x plus 1. And we're asked to find f of -3. Now for functions notations, all it is a matter of simply plugging a value into a function. And here we're asked to plug in a -3 everywhere you see an x in x's place. So into the given equation, removing all the x's of the given equation and replacing it with -3 will look like so. Now we're going to use order of operations to solve this. So recall the order of operation. Please excuse my dear Aunt Sally. Means to do the parentheses first, then the exponents, then the multiplication and division, and then addition and subtraction, all moving from left to right. So that means that we would have to do the exponents first, which is -3 squared. -3 times -3 is +9. In the back here, we can also go ahead and multiply a +2 times -3, which is -6. Next, using order of operation, we're going to multiply -3 times +9, which is going to give me -27. Moving from left to right, we come to combining a -27 with a -6. That's going to give me -33. And now combining a -33 with a +1, signs are different, subtract, take the sign from the larger number, is going to give me -32, which is choice D. And there you have it, function notation and evaluating functions.
Number 12. Which of the following is the graph of a function? So what is the correct answer? Choice B. Recall a graph is a function if it passes the vertical line test. The vertical line test states that a relation is a function if and only if no vertical line intersects the graph of the relation at more than one point. So it cannot touch in no more than one point. So let's draw a vertical line through these graphs to see how many times that the line intersects the graph. Notice B is the only line that passes the vertical line test.
In this example, we're asked to identify the domain and range of the following graph. So domain, recall, is how much the graph extends or expands from left to right or on the x-axis. In other words, how far does it go to the left and how far does it go to the right? So we can see here that our graph, this parabola here, it will start at -4, and then in terms of moving to how far it extends to the right, well, it's going to keep going forever and ever to the right because you have these two arrows at the end of both ends of the parabola. So it's going to go on forever to infinity to the right. Now to the left, it only extends to -4. So recall to write that. That would be brackets starting at -4, comma, going all the way to positive infinity. And remember, we always close infinities with a parentheses. Now let's take a look at our range. Range is how much my graph expands up and down. In other words, how far does it go up and how far does it go down? Well, we can see here that because this graph, again, has arrows on both ends, I don't care how you move, it's going to go forever and ever up, and it's also going to go forever and ever down. So in terms of our number line here, any numbers up are your positive. Any numbers down are your negatives, which means that because it has an arrow pointing upward, it's going to go forever up. Now, don't think of it as it's going to the side. We're talking about, when the range, we're talking about the y values. So it's going to go forever up, and because it's also in the negative space, it's going to go forever down. And remember, when we use infinity, we always close infinities with a. Okay, so now it's time to write these in interval notation form. Let's start with our domain again. Remember, our domain is how much it expands to the left and to the right. So our graph started at -4 and it went on forever to positive infinity. And so to write that, recall, it would be brackets -4, comma, positive infinity. Remember, always close infinities with a parentheses. For our range, recall our range was moving forever and ever up and forever and ever down. Range is always how much it goes up and how much it expands down. So that was from negative infinity to positive infinity, and we always close infinities with a parentheses. So that would leave us with a correct answer of choice B. And there you have it. In this example, we're asked to evaluate f of -5. When you're given a graph and you want to evaluate that function, you're going to, whatever number you have inside the parentheses, recall that's your input, which is your x value. So on the x-axis, you're going to go over -5 so that you'll be able to find out where that graph lands in terms of its y value, its output. So again, we're from the point of origin, we're going to go over -5. Our graph is down, so let's see how much do we have to go down in order to touch that graph. That would be 1, 2, 3, 4. We're now on that graph. So that means the ordered pair of y that corresponds to an x value of 5 would be -4. So that would be an output of -4. So again, over -5. To be on the graph, you would have to go down -4. Down is a negative. The ordered pair here, again, is -5, -4. The y value that corresponds with a -5 would be -4. So your answer choice is D, and output in this function of -4. In this example, we're going to be modeling linear equations. So the information in the chart below gives the salary of a person for the stated years. Model the data with a linear function using the points 1, 24,300 and 3, 26,700. So we were given two values there, and we're asked to model the data with a linear function. All that is, hey, write an equation of line. So remember, to write an equation of the line, you need 2 bits of information. You need to know the slope, and you need a point. So first, let's go ahead and find our slope. We have our 2 points, so all we need to do is plug it into the slope formula of y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So plugging those 2 values into the slope formula is going to look like so. You can go ahead and get your calculators out and calculate the top and then the bottom. And what you should have gotten if you've done it already is 2400 over 2. 2400 divided by 2 is going to give us a slope of 1200. Now that we know the slope, yes, you could plug it into the y equals mx plus b formula, but we don't need to do that because we have some very valuable information in that table. If you notice when you're writing a line, we have the y-intercept. Anytime you have an ordered pair where 0 for x and some number for y, in this case in our chart we have 0, 23,500, so 23,500 is our y-intercept. So we have our line. We're ready to write our line. Y equals our slope 1200x plus, in the back is your y-intercept, which is 23,500. And there's our line. There you have it, which is choice B. This problem deals with modeling linear equations. We're given the linear function f of x equals 270x plus 5295. This function provides a model for the number of cases of a product sold from 2010 to 2020, where x equals 0 corresponds to 2010, x equals 1 corresponds to 2011, and so on. We're going to use this model to find the number of cases sold in 2018. Now, if this pattern were to continue with x equals 0 being corresponding to 2010, 1 corresponding to 2011, and so on, you're going to find that the number then that would correspond to 2018 would be the number 8. So what that means is we're going to evaluate this function for 8. In other words, plug in an 8, find f of 8. So you're going to remove all the x's of the given function and replace it with 8. Now go ahead and get your calculator out and go ahead and do the calculation of 270 times 8 plus 5295. And what you should get as an output for the number of cases would be 7,455, which is choice D. Okay, that's it for this review. I hope you found it helpful. Stay positive, stay focused, study, and make it happen.